Alright, we're going to do two sections today, 3.1 and 3.3. 3.1 is all about lines, and 3.3 is all about parabolas and quadratic functions. So they should be pretty much review, so I may go through it pretty quickly, but we'll have time in class to go over it. Alright, if you look at this chart here, first thing, linear functions always have an average rate of change that is equal to the slope. So for instance, if you look at this chart, if you look at the x values, you notice they're all going up by 1, up by 1, up by 1. Now look at the y values, the f of x, they're going down by 3, down by 3, down by 3. So if we talk about average rate of change as being slope, I say the change in the y's is negative 3 over the change in the x's, which is 1. All right, that was supposed to be a 3. So the average rate of change is negative 3. Now look down at the next set of points. If I go from 10 to 7, average rate of change for the y's, down by 3, x's, up by 1. And if I do that for all values in this chart, I end up with the exact same number for all of these. Negative 3 is all the way down. Now, just for quick practice, let's go ahead and graph one, and then we'll notice that the average rate of change is the slope, and then we'll answer this increasing, decreasing, or constant. Whoops, typo. That's supposed to be a t. Constant, and then we'll go from there. So if I look at f of x, we hopefully by now know y-intercept of 4, so big dot on 4. Slope of negative 3 means down 3, 1, 2, 3, over 1 to the right. And so I have a slope of negative 3 looking like that. So when you're asked a question, what's the average rate of change, we should automatically be able to say it's just negative 3. Now, if you look left to right, the y values start way up here, and they end way down here. So if I look left to right, I would say this is a decreasing line. Okay, now just for practice, let's graph two lines on the same plane, and then we'll answer a couple questions, B, C, and D down here about them. So if I graph f of x first, let's graph it in blue, and I go up to 5 y-intercept, up 3 over 1. This blue guy here is f of x. And these don't have to be perfect. Don't grab a ruler or anything like that unless you really want to. Same thing with g of x, up to 1 for y-intercept, down to over 1 this time. Here's my negative slope, g of x. Okay, now let's talk about things graphically and algebraically. So if I look at part B here, solve for f of x equals 0, well, I can kind of see where it's happening. It's right here. That's where y would be 0, and I need to find the x-intercept. And just so the graph isn't perfect, so let's do the algebra as well. So if I'm solving f of x equals 0, set it equal to 0, a little bit of solving, and I get negative 5/3. So it's good to be able to do it algebraically because it's not always going to be a nice x-intercept. Okay, next one over. F of x equals g of x. I want to know where do they hit each other. So now I'm talking about this point right here, where they intersect. So f of x equals g of x. Let's set both functions equal to each other. And again, a little bit of solving, and I'll get negative 4/5. Okay. All right, now this next one's kind of a good one to talk about for later on especially. When is f of x greater than or equal to g of x? In other words, when is the blue one above the red one? So if I'm looking at my blue, I would say this branch of blue is above the red, whereas this branch of blue is below the red. So I kind of know where it's happening. Now let's put the algebra to it. So if I set f of x greater than or equal to g of x, and I solve, so f of x greater than or equal to, here's my g of x function, I end up getting this number, x greater than or equal to negative 4/5. And that makes sense on our graph, because if this little guy here in the middle is negative 4/5, I want everything bigger than or equal to that. Alright, and now everybody's favorite word problems. Don't get scared by these, just read them kind of slowly. This one's about talking on a cell phone. The cost, c of x, is your y value. X is the number of minutes you speak. So part A says, what's the cost if you talk on the phone 50 minutes? Alright, 50 minutes, that's my x value. So I'm going to go in here, find c of 50 minutes, cost at 50 minutes. Plug in, plug in. This would definitely be a calculator question. And if I do all that properly, grab the calculator, I get $24. Alright, so just know where you put the x. And then part B is the other version. What if you budget yourself $60 per month for the phone? So $60, that's your cost. So that's my y value. So when I go to plug it in, the 60 is going to come over here on the left, set it equal to the function, right? Magic algebra, and I get 144 minutes. That's the max number I can talk. If you put on a calculator, it's 144 point something, but you can't go over that, so we got to call it 144. Okay, now if we look at the next page, now we're talking parabolas, quadratic functions. And if you look up in here, it does say memorize. Chances are you probably have most of this memorized already. But the one thing I do want to focus on here is this discriminant. If you take a look at these three graphs I'm about to draw down here, I want to know, when would a quadratic, when would a parabola have two solutions, one solution, or no real solutions? So visually, let's talk about that first. Two solutions means my parabola, right side up or upside down, it doesn't matter which, hits the x-axis 2 times. All right? One solution means my parabola hits the x-axis 1 time. And then the no real solutions just means it's floating up in space somewhere. It could be up here, it could be pointing downward, as long as it never touches the x-axis. Now what we talk about is, how does that discriminant help me? Well, this b squared minus 4ac thing, if it's positive, greater than 0, that gives me my two solutions. If this same discriminant equals 0, there's my one solution. And then same spiel, discriminant negative, imaginary, means no solutions. Okay, here's where the most algebra in the whole lesson comes in. If you look at the next page, I need to find vertex form for parabolas by completing the square. And we've completed the square already this year, but with parabolas it looks a little funny because the f of x, the y, stays put and everything else stays on the right side. So let me show you or remind you why that makes things just a little bit different. Okay, completing the square. We know we need to lump our x's together. I'm going to slide the negative 7 away. When we go in to complete the square, we're going to add 1 here. Now, since everything's staying on the right, instead of adding 1 to the left and the right, I'm going to add 1 to the right, then subtract 1 also on the right. So now take a look. Here's my vertex form. All right, x minus 1 squared minus 8. And then if you think of one of that formula we had to memorize with the h's and k's, that means my vertex is at 1, negative 8. This guy, because the x squared is a positive, it would have a minimum value, so it's going to point up like this. All right, now if we go into graph, I always want the vertex and 2 more points. The easiest extra point is the y-intercept. You can pick any point you like, but think about this. If x is 0, and I come back to this original equation up here, if I plug x as 0, all you're left with is negative 7. And since parabolas have a mirror image, take a look at what happens when I graph. Here's my vertex, 1, negative 8. Y-intercept, 0, negative 7. And then again, mirror image means there's got to be another point on the other side of the vertex like that. So this would be my parabola. Now if you look down here, now that I have this parabola in full view, I can answer a ton of questions about it. The axis of symmetry means, where can you fold this guy in half? Well, you can fold it right down the vertex. So axis of symmetry is x equals 1. It's a vertical line. What's the domain? It's always all real numbers for parabola, no trick there. That's your domain. The range is always based on the y-coordinate of the vertex. So if the y-coordinate of the vertex is this negative 8 down here, that means, oh, that should have been a square bracket. That means my range is negative 8 all the way to infinity. Now, one more question about this, increasing, decreasing. It always increases and decreases up to the x value of the vertex. So this guy here, from negative infinity to 1, would be decreasing. From 1 to infinity would be increasing. All right, next example over is just a tad harder because it's got this negative 3 hanging out front. So if I do this correctly, don't forget, we have to take the negative 3 out. Don't divide the whole thing by negative 3 because then it gets a little funny on the left side. If you start dividing everything by negative 3, then you have something like f of x over negative 3, which doesn't make a whole lot of sense. Excuse me. Okay, so here we go. We're completing the square, plus 1. But really, I've done negative 3. I haven't just added 1. I've actually added a negative 3 in there, which means to balance, I need a positive 3. So then my vertex form looks like this. There's vertex form. Okay, so vertex on this one would be 1, 7. It's going to have a max this time because the negative in front means it's pointed upside down like this. And then for the additional point, that again, the y-intercept is always the easiest. So the y-intercept for this guy, if I plug in 0 for the original, I get 4 back. A lot easier to graph. Okay, so here we go. Vertex is at 1, 7. Y-intercept is at 0, 4. And then again, that mirror image on the other side of the vertex gives me this guy. Let's answer all the same questions about it. So what's the axis of symmetry for this one? It just happens to be the same, x equals 1. What's the domain and range? Domain, always negative infinity to infinity for parabolas. Range based on the y value of the vertex. So this guy's going to go negative infinity all the way up to 7. All right, this time from negative infinity up to 1, I'm going to be increasing. From 1 to positive infinity, I'll be decreasing. All right, last page. Now, let's go backwards. What if I give you some information about the parabola and I'm asking to know what its formula was? So let's start first with this formula that we have to memorize. Here's vertex form of a parabola. Okay. And then if I look at the info they've handed me, the vertex is always HK. And if they hand me a point, that's just going to be my XY. So if I plug everything in, I have everything except the A value. So if we go with plugging everything in, here's what it looks like. Negative 2 equals, A is what I don't know, X is negative 4 plus my H, and then plus my K. And now, a little bit of work here. So that's going to be 2 squared 4A plus 6. Go around and solve for A, and I get negative 2. So my final answer, make sure you clean it all up for final answer, f of x equals negative 2 in the front, x plus 2 squared up, plus 6 at the end. All right, now this last example I want to talk about in class tomorrow. If you're brave, you want to go ahead, give it a shot, but this is kind of an important one, so let's hang off on this last one until class.